Ladies and gentlemen, for those joining us again from yesterday, welcome back. For those joining for the first time, trusting that you will learn something, pick up something useful to take you into finals. Today we are going to tackle analytical geometry, another great section to secure some good marks. Again, how we'll run things today is we're going to be working through some questions from 2025's June-May rewrite. To my knowledge, there isn't a memo currently available for this paper. And so if you are uncertain of method, please again check with your teacher, educators. I encourage you to just, if you feel like you need to elaborate a little bit more on a specific question, please feel free to do so. And then we will try our best to get to some of 2024's end of year as well. That memo is available to the learners online. Again, you can just ask your teacher. So I will let you attempt it. Obviously, analytical is a little bit of a larger section than statistics, so you'll have a bit more time. Again, ladies and gents, in your respective venues, I encourage you to attempt these questions. Again, practice is key. Yesterday, we saw that with all the questions we went through, some of these questions repeat themselves, and that's, again, how we prepare for finals. We make sure we expose ourselves to as many questions as possible so that we are set up for when those questions might appear, or if they do appear in the final exam. So you'll know how to tackle them, and there won't be uncertainty, and you'll get confidence along the way as well. So again, please don't just sit and watch the video with the sound on. Do try these questions in your respective venues. Breaking up analytical geometry, it is a massive section in paper 2. I mean, in paper 2, we're only writing on 4 broad topics, which is stats, analytical, trig, and Euclidean. Our paper looks like it's going to be split again by a weekend. Ladies and gentlemen, you cannot spend Friday, Saturday, and Sunday just preparing for your paper 2. Everybody tends to prep for that paper 1 that you write on the Friday and then use the weekend to prep for paper 2. It's 4 topics, but these are massive sections. Analytical is no different. So 40 marks plus minus 3 out of the 150. And like statistics, it's taking all the way from grade 10. Right, so the content that we were taught in grade 10, that follows us through all the way until matric. Looking at that grade 10 topics, we have distance with the distance formula, midpoint, finding the midpoint coordinates of a line segment, and sometimes, again, with most of these, again, they work forward and backward. So I can ask you to find the distance of a line segment. I can also provide the distance of a line and ask you to find one of the coordinates or a variable in one of the coordinates. So again, you must know that these formulas work both ways. Gradient, we are very familiar now with our gradient formula, but we must also be aware there are other ways to find the gradient of a line segment. From grade 10, we know that if lines are parallel, they share the same gradient, and then perpendicular lines, the product of their gradients equal -1 when we multiply, obviously, the gradients together. So that's what we're pulling from grade 10. Grade 11, we then focused on the angle of inclination, as well as using that to find angles away from the x-axis, tan theta equal to m. With this formula, I want to stress again, ladies and gents, that tan theta equals to m is at the x-axis, right? So working out the angle of inclination, so it has to incline from somewhere, and that somewhere is the horizontal x-axis. So if they do ask you to work out an angle away from the x-axis, there are multiple ways. You can move over to using your trig rules, so maybe sine rule or cos rule. There is also this formula that you can use. Some may be familiar, some might not. But again, you can also just use angle of inclination, work out the angles at the x-axis, and use things like interior angles and exterior angles of a triangle. We then also focus on the equation of a straight line, spoke about collinear lines, where the gradients are equal. Collinear points should also be in here somewhere. Those are obviously points that lie on the same line. And then median and altitude. I don't think we use these concepts, this terminology in papers anymore, but be familiar with what these concepts are so that you know how to then go and find those equations of those lines. So that's what we tackled in grade 11. And then we know in grade 12, we move into the equation of a circle, as well as the equation of a tangent to a circle at a point. And then also just general things like proximity is what I call it. Does a point lie inside, outside, or on a circle? When we look at two circles, do they intersect? Do they touch exterior at one point or interior at one point, or do they not touch at all? So familiarizing yourself with these kind of things will set you up well for your analytical. If you know these things, the analytical section will go well for you. Now, when you look at a section like analytical, same like with stats, there are some super routine questions here. Find the distance of the line, find this angle using angle of inclination. It can get a bit trickier. Today's question selection does span, level 1s to level, I'll say level 3s. I don't know if the one will count as a level 4. But again, for the most part, you will see that these are questions we've practiced over and over again, and we should be fine for them. The other thing I want to just mention before I get into these questions, ladies and gents, is that we are working in analytical geometry. But if you have worked through enough past papers, you will see a trend as of late where, number one, they will definitely within the paper mix up a little bit of concepts. So even though in analytical geometry, if they are asking us for the area of a triangle, we need to go to the fact that I could either use half base times perpendicular height, or I could use my area rule from trigonometry. Because we deal with circles in analytical, the equation of the circles and equation of tangents, we must be prepared that they could throw some Euclidean geometry in as well, where we'll have to use some of our circle theorems. So again, although we are in analytical geometry, always be aware of the tools from other concepts that we can still use there. And with, again, like with the question selection today, there is going to be some where we'll have to use a lot of Euclidean, maybe a little trigonometry. Okay, let us get straight into it. Again, any questions, pop it in the chat. Mrs. Cox will let me know if there's anything urgent that requires my attention, and then please feel free to complete the attendance register whenever you can if you have not done so already. Right, first up, ladies and gents, we are going to take a look at the May-June rewrite that they wrote this year. Question 3, again, I'll actually just jump quickly. Looking at May-June, usually the breakdown is an analytical question that requires a lot of grade 10 and 11 content, and then afterwards a grade 12 sort of analytical question where there's circles and that. Again, we'll still use the tools from both, but that's usually how it's sort of broken up. Okay, right, we're going to be looking at this question 3. It's 21 marks, ladies and gents. I am going to give you 21 minutes. Go for it, and I will see you soon. We'll hear from you soon at least. Okay, ladies and gents, hopefully you had some fun with this question. Let's get into some of the answers. Right, so the diagram they present us with below, triangle SRT, is drawn where R lies on the x-axis and S lies to the left of R. T lies on the y-axis, so the y-intercept of both RT and ST, and the coordinates of S are provided. They give me M, a variable, and they give me the y-coordinate 1. They give me the equation of RT, the straight line, and they tell me it's 2x minus y plus 10 equals to 0. Now, the first thing I notice about that straight line is it's not in standard form, right? So in order to work with it, I'm going to get it into standard form, and then I will have it obviously help me answer some of these questions. So again, you should have these questions available to you. Let me just double check if mine's actually available. Here we go. And so I'm going to switch over to my projector now so that you can see me going through the questions with you. Okay. Right. Again, if it's not clear enough, do let me know, and then I will always just switch over. So 3.1, they asked me to calculate the coordinates of R. Okay. So R, firstly, as I mentioned before, that equation that they gave me of RT that wasn't in standard form, what I'm going to do very quickly is I'm going to take that y over, just so that I can get it into standard form, and then it will just make it a little bit easier to work with. So that is what we're familiar with when it comes to the straight line format. So with 3.1, knowing that this is the equation of that line over there, right, R is just the x-intercept. So what do? We let y equal to 0. Now, you don't even need to get it into standard form in order to do that. You can just let y be 0 straight away. Divide both sides by 2, we end up with x being negative 5. They did ask me for the coordinates of R, and so what I'm going to do is I'm just going to ensure that I do write it in coordinate form for them. X is negative 5 when my y is 0. 3.2, they now want the length of the line RT. Now, or I have the coordinates 4. Anytime they're asking me for length, ladies and gents, I must go straight to distance formula. Now, the thing about these formulas, just very quickly, they are on the formula sheet. So please do use the formula sheet when you're subbing into these formulas. Because the formula is on the formula sheet, you're not getting marks for writing. Hi.
Sorry to interrupt. Can you move your page a little bit down just so we can see coordinate T as well?
Okay.
A little bit more? Perfect. Thank you.
Okay, I'll keep moving it up and down to refer to the diagram. So as I was saying, with our formulas, because it's on the formula sheet, you're not getting a mark for writing the formula. Most of the time you get a mark for substituting into the correct formula. So ladies and gents, please go and look at the formula sheet if you're not familiar with the formulas, right? You don't want to lose marks because you're subbing into the wrong formula, especially when it's a routine question like this. Right, so distance formula, we know we need the 2 coordinates on the line. We already have R. T, we don't have a coordinate for. But we know that T is the y-intercept of line RT, and that is my C value over there in my standard form. So that's why it's quite helpful to get it into standard form. So T then, we know has the coordinates 0 and 10. 0 obviously because it's on the y-axis, having an x value of 0. Now that I have those 2 coordinates, I can just substitute it straight into my distance formula. I like to say y2 minus y1, so I'll say 10 minus 0 all squared plus 0 minus minus 5 all squared. Okay, now very important, quickly worth mentioning here, you don't want to mix up your x2 and your y2 and your y1. So if you really do struggle with it, again, you don't want to lose unnecessary marks here, ladies and gents. Go label your coordinates. You can then call this your x1 and your y1, and you call that your x2 and your y2, okay? And you sub in accordingly. Don't go and make a simple mistake like that. About that. And so we sub in accordingly. Now, don't work out piece by piece, ladies and gents. Please just type it into your calculator so that you know you're guaranteed to make it right. And then type it in the way that you see it that you have substituted into your equation, right? So 10 minus 0 all squared plus 0 minus minus 5 all squared as well. Okay, equals to, and we get 5 root 5 as my answer for that distance. Okay, they also do request in the question that I leave it in surd form, and so I'll leave it in surd form as it is over here. Surd form obviously having that root over irrational number, or at least, sorry, the root over non-perfect square. Right, 3.3. I'm going to zoom out a bit so we can still see the diagram. With 3.3, they ask me over there, if it is also given that 2RT squared is equal to 5SR squared, calculate the value of M. Now, M we see is part of S's coordinate, so SR, right? And what they've given me there is basically an equation that I can use to get that distance SR alone. Do we see that if I have that distance, right, the length now of SR, this is what I was chatting about earlier, where either they can ask you to find the distance, as they asked me to do here, or they can give me a way to have the distance, which they're doing in this question. I can use that now, reverse to go and solve for M. So let's first go and work out that distance of SR. So I'm going to use the equation they provide me with. 2RT squared is equal to 5SR squared. We have my RT over there, so I'm going to sub it in. Remember, RT is the entire length, 5 root 5. And so I'm going to place that entire thing in brackets squared equals to 5 SR squared. Now my job is to get this SR squared alone, right? So what am I going to do both sides? It's 5 times SR squared. I'm going to divide by 5. So my SR squared then will just be 2 5 root 5 all squared divided by 5. So SR squared has a distance of 2, my bracket, 5 root 5 all squared all over 5. And I get a length of 50 for SR squared. Now what you'll notice me doing quite a bit is I will try my best to type it once in the calculator. That also avoids me making maybe an input error on my calculator somewhere and then losing my marks. Okay. Again, up to you. That is just what I recommend as maybe a little bit more helpful. Okay, something like this now where I type it once instead of working out piece by piece by piece. Right, so I have my SR squared. I can get SR alone by square rooting both sides, but I'm going to leave it as SR squared, and I'm going to explain why now. My distance for SR, right, distance formula, we know that SR would equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared, right? I know that I'm now going to substitute in my coordinate for S and R over there. But what I can do is get rid of that by squaring both sides. And what I realize I end up with over there is exactly that, my SR squared. So now I can sub in freely. What I'm going to do now is I'm going to write that coordinates in over there. So I will call S as x1, my y, my y1. I'm going to leave my r as x2 and my y2 and sub in accordingly. Let's just make sure that I sub in properly. I don't mix up any x's and y's. I don't lose unnecessary marks. Remember how I got that SR squared was by squaring both sides. So now that square root is eliminated. So x2, I go over there. That's going to be minus 5. Minus my x1, I go over there. That's going to be m all squared. Plus y2, I go over there to my y2, 0. Minus y1, I go to my y1 over there, which is 1 all squared. SR squared, we know, was that 50. So I'm going to substitute that in, equals to. Now, when it gets to these binomial squares, ladies and gents, we are still fighting wars in grade 12. Please, please, please. We now know that x plus 2 all squared is not equal to x squared plus 4. You cannot go and distribute that. That is incorrect. That is a breakdown, okay? If you do not know the short way to square a binomial squared, and I'm not going to use it, right? Then x plus 2 all squared, you go and write as 2 brackets, and you go and multiply it out, distributive law, right? You go and do your FOIL or whatever you need to do over there. Please, again, taking that square in, breakdown, massive error, right? So what I'm going to do is I'm going to sort out that, let's sort out that bracket. I'm going to write it as 2 brackets, squared, because we know that my binomial squared is supposed to end up giving me a trinomial, 3 terms, and not the 2 terms that we see over here. My 0 minus 1 we can do, however, because that's minus 1 squared, so that's just going to be positive 1. So I have my 50, and now I multiply. Negative 5 times negative 5 is positive 25. Minus 5 times minus m is going to give me positive 5m. Minus m times minus 5, again positive 5m. And minus m times minus m is positive m squared plus 1. I see now I end up with an m squared. That tells me I'm going to end up with a quadratic equation. So I'm now going to get everything on one side equal to 0, because that's how I go and solve my quadratic equations. My like terms 5m and 5m gives me 10m. I add my like term 25 and 1, which gives me 26. And I'm going to bring this 50 over, which is going to be negative 50. So all I'm going to do is I'm going to say, what is my 26 minus my 50? You can do it on your calculator. It's going to be negative 24, equal to 0. And this is what I'm looking for. Whenever you see that square on a variable, you must know it is a quadratic equation, and we need everything on one side equal to 0. Next, you can either factorize it, because it's a trinomial, or if you're not comfortable with your factorization, ladies and gents, do use your quadratic formula. Again, that is on the formula sheet. Substitute in properly. I know, like you, my trinomials, and so we're going to factorize that. M times m. What products give me 24 that add to give me 10? That's going to be 12 and 2, because the signs make sense to be 12 and 2. Products equal to 0, we're going to split and solve. So m is either equal to negative 12 or my m is equal to 2. So we have 2 options here for m, and this is where we now need to refer back to my diagram over here. If I look at where s is positioned, right, this m, I'm going to zoom in a bit there so you can see, this m is where x is negative. So when I look at my two answers that I have over here, m either being negative 12 or m being 2, I know it cannot be equal to 2. Therefore, m has to be negative 12. And you have to make that selection, because very often in the memos, you'll be allocated a mark for selecting the correct one. That also doesn't mean you just ignore that. Please, you put a line through it, or you then make sure that your selection is clear. And that is how we will answer that question. So now I also know what S is. S's coordinate is going to be negative 12 and 1. Okay, why do I write it in? Because we might need it later for another question or something like that. Okay, right, moving on to 3.4. With 3.4, ladies and gents, they ask me that it's further given that V lies on ST such that VR is perpendicular to ST. Determine the equation of VR in the form y equals to mx plus c. So what they are telling me over here, ladies and gents, is that this line is meeting that at 90 degrees. Go and find the equation of VR. We know that the equation of a straight line is y equal to mx plus c. We spoke earlier about the fact that there's many ways to go and find m, my gradient, which is usually also what we look for first. So I'm going to start off by starting right there, y is equal to mx plus c. Now, I know a crowd favorite is going to use my gradient formula, all right? Y2 minus y1 over x2 minus x1. But in order to use that, I need two coordinates. I only have r over here, so I can't use my gradient formula. So that's when we go and try my other methods. Is VR parallel to another line? Why? Because then the gradients are the same. It's not. Is VR perpendicular to another line? Why? Because the products of the gradients equal negative 1. And they tell me it meets at 90 degrees, so I know that it is perpendicular. Which means that, right, sorry for that, which means that if I have the gradient of this line, which I can work out because I have these two coordinates, I then can go and work out the gradient of VR using that rule. So that is what I'm going to do. I'm going to use gradient formula now on S and on T. Right? I'll try to keep both in frame. So I go and say the gradient of line ST is going to be y2 minus y1 over x2 minus x1. I'm going to leave S as my, actually no, I'll leave T as x1 and y1, and I'll make S my x2 and my y2 now, right? And I sub in accordingly. So y2 will be 1 minus y1 will be 10 all over my x2. What did I say? Sorry, let me just see. What did I say? y1. Oh, see, I'm confusing myself here. Sorry. Y2 minus y1 over x2, which is negative 12, minus my x1, which is 0. Right? Once again, we can type that in our calculators. Okay? We can go and say 1 minus my 10 all over my negative 12 minus my 0, and I get 3 over 4. Now, what I always like to tell my students is that go and double check. This is a positive gradient. Is your line moving in a positive direction? Yes, it is. Because if I got a negative answer here, but the line is positive, you did something wrong. It's an easy way to just check that you're on the right track. Okay, so now that I have ST, I can work out VR because those lines are perpendicular. Knowing that the product of the gradients equal to negative 1. So the gradient of VR times 3 over 4 should equal to negative 1. Which means that the gradient of VR will just end up being negative 4 over 3. A nice easy way you can get that is you just flip the fraction and you change the sign. But showing that calculation also helps out. Now I know so far that y is equal to minus 4 over 3 x plus c. I need to go work out that c. We know this, we've been doing this type of questions since grade 9, that how I work that out is either I have the y-intercept, which I don't for this particular line, or I just sub in a coordinate on the line. I have r, which lies on the line, so that's what I'm going to do. I will sub in the y of r, which is 0, into the y of my equation, minus 4 over 3, and I will sub in the x of r into the x position over there. And so r x is negative 5, so I'll go and sub that in over there. That leaves me with 0 equals to positive 20 over 3 plus c. Take the 20 over 3 over, make it negative, and there I have my c coordinate. Don't forget they wanted the equation of the line, and so you just make sure that you write out the equation of the line over there. Right, easy 5 marks, okay? Again, something routine, something that we should not be leaving out, ladies and gents. Now, looking over at 3.5, they say, hence show that the coordinates of V are -8 and 4. Now, I want to bring up 2 very important things over here. Number 1, hence. Basically, they're saying use the information from the question we've just worked out. Now that we have proved that, use it to answer this particular question. Secondly, they want us to show that the coordinates are this. Now, ladies and gents, a lot of the time when they ask us to show this or prove this, the fatal mistake a lot of you make is you use this information in answering the question. You must not do that. The reason they are providing this is that we probably need this accurate information in questions that follow. So they are basically just telling you, I'm not sure why the bell is ringing so much, apologies. They are basically just telling you what the answer you are working towards should be. And so I know that when I do go and find V, my answer should be -8 and 4. So how do I go and find V? Looking at where V is positioned, V is the point of intersection of line VR and line ST. Points of intersection, how do we solve them? Very simply, you just let the equations of those lines equal. Now, we've already just worked out the equation of VR over there, right? So all I actually need is the equation of line ST. What we've done in a previous question is we worked out that the gradient of ST was 3/4, as you can see over there, right? So I write my X. As I mentioned, my C value is just my y-intercept, and is the y-intercept of that line not just T, which is 10. So that's a nice, easy way to go and work out that equation. So all I'm going to do now, ladies and gents, to go work out what the coordinates of V is going to be, is I'm going to let the equation of ST equal the equation of VR that we just found. So I will go and say, where does -4/3x minus 20/3 equal my equation that I found of ST, which is 3/4x plus 10. Right, that's all I'm doing over there. This equation equal to this equation is how I work out that point. Because that point is where those lines equal to each other. I'm going to bring my -4/3 over like terms. So 3/4x plus 4/3x. And at the same time, I'm going to take my 10 over, which will have me have -20/3 minus 10. Okay, get your calculator out. -20/3 minus 10. That's -50/3 equals to my like terms of 3/4 plus 4/3. I get 25/12. Don't forget that's x. Right? To get x alone, either we can divide both sides by 25/12 or times by the inverse 12/25. I'm going to divide, so I'm going to say -50/3, right, which is that answer over there, divided by my 25/12. And I end up with x having an answer of -8, which matches up to what they told me. Remember, I still have to go and find the y value. So because x of -8 lies on both lines, you can decide, are you going to sub it into that equation or that one? I'll sub it into this one. No particular reason. Y is equal to 3/4 times the x I just found plus 10. And that will leave me with a y value of, okay, let's just do it on the calculator, 3/4 times -8 plus 10. And we end up with 4. That should be, if I did it correctly, the coordinates of V, and that indeed is the coordinates of V. So that's how we show that V indeed is -8 and 4. Right, that is 3.5. What I like to do, and you've probably seen me now do it as I work through the question is, and I'm going to write that in. So if ever I need to interpret anything on my diagram, I have all of these coordinates. I have R, I have T, I have V, and I have S. Okay. Final question. They tell me if R prime is the reflection of R about the line x equal to 1, calculate the area of that quad, RVT, R prime. Now, the first thing we need to know is, where does this r prime lie? They tell me it's a reflection about the line x equal to 0. What has the equation x equal to 0? That's your y-axis, ladies and gents. Right, because remember, these special lines, vertical and horizontal, they're equal to the axes they cut. So we know that this line is cutting the x-axis at 0. What line cuts the x-axis at 0? My y-axis. So all that is happening is r is being reflected about the y-axis to go and form r prime. And then they want the area of the shape that T, R prime, R, and V makes. So what I've done is I went to go and draw R prime of this so we can take a look at what that shape looks like, and then break up how we're going to work out the area of this particular shape. Now, the first thing that I think is important to note is that this is an irregular quadrilateral, right? So there's no standard formula for this that we have knowledge of, which is fine, ladies and gents. So how do I answer this? I break this up into shapes that I do know. I see there are 1, 2, 3 triangles over here, but to make my job a little bit easier, I'm actually going to break it up into this triangle, triangle RTR prime, and I'm going to break it up into this triangle, this VRT triangle. And I'm going to work out the area of those triangles respectively, and then add them together to get the area of the whole shape. Remember, I know that that is 90 degrees, so it's easy to work out that area. I also know that my y-axis meets my x-axis at 90 degrees. Now, why is that important? Because no matter which section of mathematics you're working in, analytical, trigonometry, especially now Euclidean with our grade 12 work, whenever they ask you for the area of a triangle, ladies and gents, your mind needs to go to two things. Either it's going to be my half base times perpendicular height, or it's going to be my area rule, half AB, sine of the included angle C. So please be familiar. It doesn't matter, oh, I'm working in Euclidean, so it must be the half base. No, you always decide between those two. It depends on the information provided. The fact that I have right angles over here, this is going to be my option, the half base times perpendicular height. So all I need to know is what the bases and the heights are. Okay, remember the base and height is interchangeable as long as those sides are meeting at 90 degrees. So I have R over here. Remember from our previous question, I said that this is -5 and 0. Because it's a reflection over the y-axis, I know the distance from R to origin is the same distance from origin to R prime, which means that this is going to be +5 and 0, right? I know that T was 0 and 10 from the y-intercept, and so this height over here is going to be 10 units as well. Why I say as well? Sorry, because...
Sorry to interrupt.
Yes?
There's a request that you use a darker color pen.
Darker pen?
Yes.
Okay, maybe let me see, does this help out? Where's this lamp? Is this a little bit better?
That is a bit better, thank you.
Okay, maybe I'll even zoom in a little bit more. Okay. Causing the writing to be unclear. Oh, sorry. Okay. Is that a bit better? Just a thumbs up there from that user.
That is
okay,
clear.
I'll switch over for, yeah, it's the last question, so I'll switch over to a thicker pen for the next one. Okay. Right. So looking at R to R, this distance over now, since I'm saying this is going to be my height, I need the length of the space. We know I can just use the absolute values, the positive values. So this would be 5 units over there, 5 units over there, which also makes that base 10 units. So that's how I'm going to work out the area of this first triangle, RTR prime, right? So let's take a look at that. I'm going to say, looking at the area of triangle RTR, that's going to be half by my base of 10 multiplied by my height of 10. That's obviously going to then be 50 units squared. Okay, triangle 1 sorted. Now I need to turn my attention over here to this triangle. And now working with this triangle, remember we have these coordinates. V, they've told me, has the coordinates, what is V from the previous question there? -8 and 4. -8 and +4. So it's very easy now for me to go work out what this length is and what this length is. I will just go and use my distance formula. Okay, so I'm going to sub now into my distance formula. And I'm going to say VT is equal to, now I'm going to sub onto my calculator just to save a bit of time, right? We have obviously the coordinates, so I'm going to say the square root of, let's go work out VT first, like I said, so 10 minus 4 all squared plus 0 minus 8 all squared, and we get VT has a length of 10 units. Looking at VR, I'm going to do that same calculation. So I'm going to say y2 minus my y1 all squared plus my x2 minus my x1 all squared. And I get a length of 5 units. And so now I have the lengths of this triangle as well. VR we said is 5 and VT is going to be 10. Same thing again, here's my 90 degrees, where my base and my height meet. I'm going to go work out that area. So the area of triangle RVT is going to be equal to half times my base times my height. Again, don't stress about the order of these two as long as it's the sides that meet at right angles, which is the case over here. It's the sides meeting at the right angle. That's going to be 50 or half is 25 units squared. And this now is the area of triangle 2. So I've basically worked out the area of all the shapes that make up that irregular quadrilateral. Don't forget the actual question was, what is the area of that quadrilateral? So the area of RVT or prime will just be the sum of those two triangles, 75 units squared. Right, I'll just zoom out a bit there so we can see the calculation with the diagram. Okay, and that is that 5-mark question. Again, usually stuff like people leave out, but ladies and gents, you do have the knowledge to go and answer them. Again, I always also tell my kids that this 5 marks is not for the answer only in this case, right? You get marks as you work through this question. So attempt these questions, don't leave them out. Maybe this one was a little bit trickier to see area-wise, but this one we can see it's a nice right angle over there where it has a nice height and a base. So at least start, because then you can secure marks along the way to the answer. Okay. If you have any questions on this, please do ask. Again, like I mentioned yesterday, I will tackle any questions you had issues with at the end of the session. If you do have, we're going to move on to the next question now. That was question 3 from May, June, ladies and gents. We're now going to tackle the grade 12 content from May, June 2025. It's 20 marks. You have 20 minutes. Go for it. Yeah, hopefully I had fun with this one, especially 4.7. A few ways to do that one. So again, the chat is there, ladies and gents. If you want to pop in your answer, let us know what you got. If you also want to share your method, the way you worked it out, by all means, feel free to send a picture as well. Okay, so moving through this, again, you should have the questions there. I'm going to move over to my document viewer. I have changed to a black pen. Hopefully that makes it a little bit more legible. If not, again, please just let us know and I'll change over to maybe a thicker marker. 4.1, while we have the circle over here, they tell me EC is a tangent, E has the coordinates -1 and 3, M is the center of the circle. They also provide me with the equation of the circle, and they tell me that line CM cuts the circle at T. C has the coordinates -7 and P as well. All right, getting into it. 4.1, write down the size of CEM. That's where we find CEM. And this is exactly what I was chatting about earlier. This is us using our circle theorem, tan perpendicular to radius. We know that tangents meet radii and diameters at 90 degrees. And so we know that that is just going to be 90 degrees. No reason required. We are in analytical geometry. Unless they state to give it with a reason, we don't need to support any of our statements with reasons. Again, Euclidean, please, reasons, incredibly important. 4.2, they want us to determine the equation of tangent EC in the form y is equal to mx plus c. Now, at the beginning of the session, we spoke about some of the things that you need to know. This is one of those things you need to know, ladies and gents. You need to know how to find the circle center radii from an equation. You need to know how to write the equation of the circle if you're given the circle center and the radii. And then you also need to know how to work out a tangent to the circle at any point. Okay, these are routine questions. Look at it, it's for 4 marks, and it's 4 marks that you can definitely achieve in a paper. So how do we do this? Again, we need 2 coordinates to find gradient. We only have E as a full coordinate. We don't have C's full coordinate. So we're going to use the fact that we know radii meet tangents at 90 degrees. Similar to what we did in the previous question, if I can work out the gradient of this line, I can work out the gradient of that line, knowing that the product of the gradients equal to -1. So how do I work out that line? I need to go and work out my circle centers coordinate, sorry. And very simply, we just pull that from the equation itself. M then will be, remember we change the signs when we're moving from that equation. So that's -3, excuse me. Apologies. That's -3, so my x-coordinate is going to be +3. And y at the moment isn't supported with anything, and so we know then that means that y value of the coordinate is going to be 0. So 3 and 0 will be my circle center. Now I have enough information to work out the gradient of that line, so I'm going to work out the gradient of line segment ME. We know that that's the change in y over the change in x. Once again, if you are uncertain, you go and label it x1, y1, and x2 and y2. So I'm going to say y2 minus y1 all over x2 minus x1. What do we end up with over there is -3/4. Okay, makes sense again, negative gradient, negative line segment. We know the product of the gradients equal to -1, and so the gradient of my tangent EC then will be flip that fraction 4/3, change my sign, positive. Again, we can sub it into my equation to go solve for that 4/3. Now I know that y is equal to 4/3x plus c. Same thing as we did before. To go work out that c, I don't have that y-intercept. I don't have that y-intercept up top over there, so I need to sub in a coordinate. The only coordinate, the full coordinate I know lies on that line is E, so I'm going to sub in E. When y is 3, my x is going to be -1. That just comes from E's coordinate with the x of -1 and a y of 3. And now I solve. 4/3 times -1 is -4/3. When I take that over, it will become 3 plus 4/3 is equal to C. Taking it up here, 3 is 9, plus 4 is 13/3, and that's going to be my C value. Therefore, the equation of this tangent is going to be 4/3x plus 13/3. What I like to do is just, does my information make sense? What I mean by that, positive gradient, positive line. 13/3 is, what's that, 4,3. Does that make sense to be +4? Yes, it does. Okay, so then my equation makes sense. So a little double check to make sure you're on the right track. Okay. 4.3. Calculate the length of DM. Now, we have M's coordinate over here. We don't have D. But what we do know about D is that it's the x-intercept of the line equation we just found. So, again, a little bit of functions over here. All I do is I let y equal 0. And I solve for that x-intercept. Isolate my my term with, I'll actually take that over. Usually I like to leave my terms with the x positive, but in this case it doesn't really matter. I want x alone, so what am I going to do? Divide both sides by -4/3. Or times by -3/4. This then cancels out. I get my x alone. I'm going to whip out my calculator for this. It's going to be 13/3 divided by -4/3, and we get an answer of -13/4. And this will be D's coordinate, -13/4 and 0. Okay, Now, again, it's very important, especially when we do calculations, to always remember what the actual question was asking. They didn't want us to work out D. They wanted us to work out the length of MD. So this entire length over there. Okay. So the nice thing about it all lying on is, so anytime we're dealing with a vertical line, right? So this is what they wanted me to work out dm. We can just use those absolute values, the positive values. What I mean by that is, if this, for example, was -4 and this over here was -7, right? The distance between those two is 3, okay? Because I can just say what's 7 -4, or y top minus y bottom. Same with the horizontal. That distance to origin, that distance over there makes up dm. So what I'm going to do is I'm just going to add those two x values together, the positive versions. So I'm going to say from O to D, this is MD's distance. So from O to D, it's going to be 13/4 units. And from O to M, it's going to be 3 units. That's going to be 12 is 25/4. Or we can write it as 6,25. And that will be my distance of MD. Now again, some of you will be more comfortable using your distance formula. By all means, go ahead and do it. Okay, right, distance formula, it is analytical. You want to use distance formula with those coordinates, go for it. You will get the same answer. All right, again, ladies and gents, any questions along the way, feel free to pop it in the chat. Any clarity you need, please ask your educator in the class. I'm sure they will be more than willing to explain. All right, that's 4.3. Moving on to 4.4, excuse me. 4.4, once again, now they ask us to show that P is -5. So I'm not going to use the fact that P is -5. I am going to prove that P is -5 by calculation, right? Where's P sitting? Over there, part of coordinate C that lies on this line that we have the equation to. And so I'm just going to use the purpose of a function. Remember, the goal of a function is to connect x and y values, describe the relationship between the two. I now have that relationship and I have that x value. So I'm going to use it to go and find my y. So very simply, I'm going to say my y is P. I'm going to sub it into my equation, which was 4/3 times x plus 13/3. Again, where am I getting that from? This is just the equation that I found for this line, right? For that tangent over there. So I'm subbing it in, and my x value at C is -7. So I'm just going to type all of that in actually to go and work out what this is. So 4/3 times -7. And if we did everything correctly, this is also confirming that that equation is right, -5. Perfect. Because if my equation was wrong, then I wouldn't get -5, and then we know we did something wrong that we're going to have to go and fix. Okay, all right, that's 4.4, nice mark over there. 4.5. Calculate the coordinates of S if SEMC is a parallelogram. Okay, so I'm going to just whip up another diagram over here. I like to use inspection for this type of question. Now, this type of question is also quite a common question all the way since grade 10, I believe, right? So the first thing that we need to do is figure out where S is going to be, right? Because they're talking about SEMC. So we know that E, M, and C are part of this parallelogram. But do you agree that this S could be here, and then that's a parallelogram? S could be up here, and then this is a parallelogram as well. S could even be all the way down here, and then this is a parallelogram. So we have to look at how they name it. Number one, they actually give me a nice little help over there with that restriction. So we know x is negative, so it can't be this point up here. It has to be one of those two. But how to confirm is we look at the way that they name it. We always name around the shape in these quads. So if they're talking SEMC, here's E, M, and C. S has to then be over here. So we can name it now properly, SEMC. If S is over here, they would have called it SCEM. Are you with me? So the name is then very important to figure out where the position is. Now, the nice thing we know about parallelograms is that the opposite sides are equal and the opposite sides are parallel, which means what? That the way that I get from M to point E is the way I will get from C to point S. Or the way I get from M all the way to coordinate C is the way I'll get from E all the way to coordinate S. Very important, you always work towards that point that you're going to find. So you can decide, is it going to be M to E, C to S, or M to C, E to S. It sounds a little confusing. Hopefully when I write it out, it'll make a bit more sense. So what I'm going to do is I'm going to do M to E. That's how I'm going to get from C to that coordinate S. So what does this look like in practice? Let's see if I can get this diagram. Just give me a second to fold the page. Right, so we can see what I'm doing here with the diagram in front of me as well. Okay, so I'm going to say, how do I get from M's X to E's X? That is how I'm going to get from C's X to S's X. The way I get from M's Y to E's Y will be how I get from C's Y to S's Y. And then I'll end up with S's coordinates. M's X we worked out to be 3, M's Y was 0. That comes from my circle equation. E's X is -1 they give me. E's Y is positive 3 they give me. C's X is -7 and C's Y they've provided me with was 5 or -5? -5 over there. Okay, and now it's just a little bit of arithmetic. How do I get from 3 to -1? I have to plus, oh, that's a lie, I have to -4. Okay, so how am I going to get from -7 to S? I'm also going to -4, which leaves me with -11. How do I get from M's Y to E's Y? 0 to 3, I have to plus 3. So how am I going to get from C's Y to S's Y? I'm also going to plus 3. That leaves me with -2. And therefore, ladies and gents, S's coordinate will just be -11 and -2. Okay, multiple ways to do this. I know I've seen some other educators use different methods. I like this a little bit quicker. Obviously, the more you practice it, also the quicker it becomes. So basically, the important thing here is we want this coordinate, but we also just want to see a method, ladies and gents. Okay, so any sort of method, go for it. If you've got the same answer and you use something else, we'd love to see it in the chat. Okay, I'm actually going to stop asking for people to send stuff in the chat because I don't think people are going to. But anyway, right, 4.6. Let's take a look at that. 4.6. The question is, if the radius of the circle centered at M is increased by 7 units, determine whether S lies inside, outside the new circle. Support your answer with the necessary calculations. Right, proximity. I spoke about this a little bit earlier. Okay, you need to know how to do these sort of interpretation questions, right? And what we essentially compare to when we look at a point and a circle, right, is we use the distance between that point and the circle center, and we compare that to the radius, right? And based on that evaluation, whether the distance is smaller or larger than the radius or equal to the radius, we will know whether it lies inside, outside, or on the circle. When you look at two circles, you then look at the sum of the radii and then the distance between the circle centers. Again, that's theory that you should know. Okay, go learn the theory so that you can answer this question. Again, 3 marks, easy marks to get. First thing I need to do, since I am going to evaluate the radius with the distance between the point and the circle center, is I need to work out what that new radius is going to be. We know from my equation over here that they told me this is 25. We know that that is r squared. So to work out the radius, we need to square root that value. The square root of 25, we know, is just going to be 5. They tell me now that this radius of the new circle is increased by 7. So we plus 7 to that with the new radius of 12. So we need to compare the distance of S and the circle center to that 12 over there. And that's all we're going to do. Very simply, I'm going to now work out what is the distance MS. We know that that is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so I'm going to go label S M, sorry, we know was 3 and 0. S, we know we just worked it out to be negative 11 and negative 2. Let's call M x1 and y1. And I'm going to call S x2 and y2. And I'm just going to substitute accordingly. Try to get both in. There we go. Right, so x2 minus x1 all squared, and then y2 minus y1 all squared. Type that in our calculators and we get an answer. Let us see. The square root of minus 11 minus 3 all squared plus minus 2 minus 0 all squared. We get 10 root 2 or 14 comma 14. 10 root 2 14 comma 14. Now why is the bell ringing so much? Why 14 comma 14? The decimal form, it's just easier to compare that to 12. So I can clearly see now that the distance between the circle center and the point is larger than the radius. Therefore, ladies and gents, this point must lie outside of the circle. Why? I will show you quickly. Here's my circle, here's my radius of 12. Here's my point S. The distance from M over here, the circle center, is larger than that radius over there, so it has to lie outside. Had this distance been smaller, it would have had to lie inside. Had the distance been equal, it then would lie on the circle. Okay, and that is 4.6. Then, on to what would be considered the challenge of this particular question, ladies and gents. Question 4.7. Again, I hope you had fun with this. There are a few ways to go and work out this 4.7. I will show you the first way that I saw. I know that maybe you saw a different way. With this, I'm going to encourage, if you really want to share your way, pop a picture in the chat. If you are uncertain about my way, engage with your educator, make sure that maybe they can explain my method or show you their method to solving it. Right. So for this, I'm going to whip out another diagram over here. Okay. What they're telling us at 4.7 is that ET is drawn, right? So this point E and that point T, they're connected. And they say that after it's drawn, we want you to calculate the size of angle ETM, which is this angle over here. Now, again, it's for 5 marks. You don't get full 5 marks there just for having that angle. I mean, they might give it to you because it's very tough to get that angle just by guessing, right? But this is where I want to encourage you again. Start the question. Do something, right? Because you'll be getting marks along the way on your journey to the answer. So don't just leave a question like this out, because you can get some marks here. Right. So the way that I decided to go about this question is, I realized in the beginning, they gave me a little bit of information that ED is equal to 15 over 4. I'm now at the last question and I haven't used that information at all. Now that doesn't mean you have to use it. I just preferred to use it because obviously I was like, they didn't give it to me for nothing. But it is possible to answer this question without using that ED. So that ED is 15 over 4 units. So I'll go and write that in. We also know that angle DEM was 90 degrees from my first question, tan perpendicular to radius. So how I decided to answer this question, ladies and gents, is I decided to use this highlighted right angle triangle to go and work out this angle over there, which I'm going to call beta. Now, the other thing, a little bit of a tip over here is you'll notice that on your answer sheet, let me zoom out a bit quickly. On your answer sheet, you will see your diagram with your space to answer these questions. Use the diagram because, again, whatever you write on there, we mark as well, okay? Obviously, it would be nice to have everything presented here in the space provided. But for example, if I want to call that angle, I mean, I could call it EMD, but now I want to call it beta. I indicate on my diagram so it's referenced nicely so that the marker can see what angle you are talking about. You can't just call it M1. What is M1? M1 can be anything, okay, right? So I know especially in Euclidean, you guys like to just name angles with M1, M2, M3, but then you haven't indicated what angle you're actually speaking about, which then creates a problem when it comes to marking that particular question. So either you name it EMD or you place it there so that we can see what angle you're talking about. Anyway, I'm going to go find that angle first. What am I going to use to find it? I'm dealing with a right angle triangle there. I have the right angle there. I know that this is 15 over 4. I also know that EM is 5 units. How do I know that? It's the radius of my circle, which I used in the previous question, right? And so I know that that is 5. I'm working out that angle. Based on the information, angle, opposite, adjacent, I'm going to use my ratio, tan. So I'm going to say, let's keep that all in a shot over there. I'm going to say tan of angle EMD, which I call beta, is equal to my opposite, which is 15 over 4, all over my adjacent 5. So that angle EMD is just going to be equal to arctan of that. Okay, type it in my calculator. I go and say arctan 15 over 4 all over 5, and we get 36,8687, sorry, 36,87. Now, again, I like to just go and store these answers so I can use it at the end. You can round him off and then obviously we get the same answer. But yeah, you'll see me, I just use that unrounded and I only round off my final answer. It works out to the same, so we can also just work with that 36,87. Anyway, now I know that this beta angle over here is 36,87 degrees. Now, why did I go and work out that? Because, ladies and gents, when we connected this E and this T over here, what I realized is that it essentially forms an isosceles triangle. Because EM and MT are both radii, we know that they are both 5, which means if I can work out this angle, I'm able to work out both of those angles independently because they will be the same, right? Angles opposite equal sides. So my goal in working out beta is, this is just part of me working out this full angle. Beta sorted. Now I want to work out this angle theta. Now, how I do this is using a little bit more analytical angle of inclination. Excuse me. So what I do here, which I usually discourage in Euclidean, I always say in Euclidean there's always enough information in the riders for you to answer the questions. The only time you ever need to construct is in proofs, right? Formal proofs. We'll need to construct to prove theorems, right? But sometimes, especially your method of finding an angle away from the x-axis, you'll just need to extend some lines in analytical geometry. So that's what I'm going to do over here. This line CM, I'm actually going to extend. And the reason I'm going to extend it is because we know with tan theta equal to m, right? That works from my positive x-axis. What I mean by that is if I want to work out the angle of inclination, I work it out from my x-axis, working up to my line over there. And so this angle, do you agree with me, will be vertically opposite and also be theta. So I can use tan theta equals to m to work out that angle, using vertically opposite, work out that, and then there I have my angle, which will help me figure out my side. So a little bit of a few steps over there. Again, if you have a quicker method, by all means, do share it with us. Right, so in order to work that out, I'm going to need the gradient of line CM. Lucky for me, I know what M is, it's 3 and 0. I know what C is, it's -7 and I keep forgetting P, -5. So I can work that out quickly. So part of my steps, here we go. Zoom out so you can see the diagram. I'm going to say the gradient of CM is going to be y2 minus y1 all over x2 minus x1. Minus 5 is 5, 3 plus 7 is 10, so that gives me a half. Therefore, tan of theta is equal to a half. Theta is equal to arctan of a half. Go back here. Arctan of a half. We get 26,57. Okay, I'm just going to store that in B. Right, and now I have that angle, which means that angle DMT T, so this angle over here where I placed the theta, will also be 26,57 degrees. Now I know what this entire angle EMT is going to be. EMT will just be the 26,57 plus the 36,87. So basically my beta now plus my theta together. I state that in A and B, so I'm going to add those two together and I end up with that entire angle being 63,43 degrees. Now, ladies and gents, how do I go and work out the actual angle that I want using this? Do you not agree that this is a triangle? So to go and work out the angle they want, which they called ET, they call it ETM. ETM. All I have to do is say, right, 180 minus my 63,43. What that does is, so I have that answer over there, I'm going to say 180 minus that answer. What that does is it gives me these two alone, right? That 116,57. Now, because I know that these are angles opposite equal sides and these angles are essentially the same because those radii are the same, all I have to do to get ETM alone is after I do that, I divide it by 2. And that gives me my answer of 58,28 degrees. And that is my answer to question number 5, ladies and gents. Now, just a little bit of a mention maybe of another method. I know a colleague of mine didn't use ED at all, but instead used this large right angle triangle. And that will have you find this angle straight away, right? You can just go use distance formula. Essentially, what she did was she said, we know that that is a 90 degrees. We have C's coordinates and E's coordinates. Go and work out that distance. That is 5. And then you can also use tan to work out this entire angle in one step. And you don't have to break it up. Then the same approach, you go and use 180 minus divided by 2. That is that question 4. Now, being wary of time, it is 5 past. I would have liked, I think this is just a brilliant question, this November 2024. From this question, from let's say 3.5 down, we get to use a little bit of Euclidean. Over here, we get to do what we usually see up here in Euclidean. So I would have loved for us to work through this. With 10 minutes left, let me just see if it's maybe worth tackling some of these questions. Let us see what is happening here. 4, that's 10, 2, 4, 5. Okay, let's put into practice some of the things that we've done today. I wonder. Right, maybe let us just tackle 4.1 and 4.2 in this particular question. So it's about 6 marks. I will give you 6 minutes. Okay, ladies and gentlemen, in wrapping up, let us tackle these last 2 questions, 4.1 and 4.2. 4.1, they're asking us to work out the coordinates of L. And then finally, they're asking us to work out the equation of ST, the tangent to that circle. Now, again, there is a lengthier way where you can use equations to go and work out the coordinates of L. But knowing that M is the midpoint of PL, right, essentially that it's equidistant, we can once again use inspection. So we can say the way that I get from 3 to 1, that x value to that x value, is how I will get from 1 to L's x value. So I can see from 3 to 1, we're going to have to minus 2. So to get from M's x value to L's x value, we also go and minus 2, which means L has an x value of -1. Same thing to get from the y values. From P's y of 9 to M's y of 3, we see that we minus 6. From M's y of 3 then to L's y, we are also going to minus 6. So 3 minus 6 leaves me with -3. That is L. Again, it's 2 marks, so you're literally getting a mark per coordinate over there. So no arithmetic required. With 4.2, they're wanting the equation of ST. Again, this is now something that we've done before. We don't have more than one coordinate on line ST. But what we do know is that ST meets the radius PM at 90 degrees, right? Which means if I work out the gradient of MP, which we can use using gradient formula, we then can flip the fraction and change the sign to go and work out ST. Again, we've done this, so I'm going to do it a little bit quicker. I'm going to say gradient of MP is going to be y2 minus y1 all over x2 minus x1. That's going to leave me with negative 6 over negative 2, which is going to be positive 3. Knowing that the gradients multiply to give me negative 1, the gradient of ST then will be flip the fraction. So 3 is 3 over 1 becomes 1 over 3. Change my sign, becomes negative a third. Excuse me. Once again, we now only have the gradient, and I'm going to need to sub in a point to x and y to go and work out C. The only point that I know lies on this line is coordinates P, which has x of 3 and a y of 9. And so I sub in accordingly. Y is 9, x is 3. Use that to solve for C. Negative a third times 3 is negative 1. Take my negative 1 over, leaves me with a C value of 10. Therefore, ladies and gents, my equation of my tangent is negative a third x plus 10. Easy 4 marks. Ladies and gentlemen, we have come to the end of our analytical session together. For those that have joined both yesterday and today, I thank you. Hopefully you've learned something that maybe now is revised, that you maybe forgot, and that you can hopefully take into final exams with you. I wish you all of the best. From the district, we wish you all of the best.